So, in today's class, we're actually going to talk about, we're actually going to talk about physics. Actually, we're going to talk about physics. I will talk about work, energy, and what? And power. Now, when you come across the word work, energy, and power, what are the things that actually comes to your mind first? You say that you actually divide the term work, you relate it with energy, then lastly we work out the power. So what is work? What is work? Now, work is said to be done. Work is said to be done when a force is applied, to move an object, over a certain distance, in the direction of the force, Now, it can be likened to what? To work done. Because it said work is said to be done when a force is applied to move an object over a certain distance in the direction of the force. Let's assume we want to move this body to this position. This is position A, this is position B. Now, a force must be applied to pull or to push this object from this position to this position. But then, at this point, work is said to be done because a force is applied to push the object, and the object went in the direction, or we go in the direction of the force applied. And that makes us what? To say that force is applied, and this is what? The distance is denoted with S. I made a clear explanation of that when we're dealing with motion. So, for what? For a certain applied what? Force. Are we together? So then, you can say work done is the product of force applied to an object, and the distance moved by the object. So, for short, that is, we can now say that since we said work done is the product of force applied to an object and the distance moved by the object, which simply means that work done is equals to what? Force times what? Times distance. Work done is what? Equals to force times distance. Now, in fundamental units and measurements, W, which is work done, equal to what? Force. The unit of force is what? Is Newton. And the unit of distance is what? Is meter. Are we together? So now 1 joule. So 1 joule equals to 1 Newton times what? 1 meter. So we can say that we can define 1 joule to be what? To be the product of what? Of a Newton and what? And a meter. Are we together? I believe we're following. Which means that what? The unit of work done, is what? Is joule or 1 Newton meter. Or you write it like this: 1 Newton per meter. That's raised power 1. Now, let's solve an example. Are we together? Let's solve an example. A force of 10 Newton is applied. A force of 10 Newton is applied. A force of 10 Newton is applied to move a bag of cement of 50 kg through a distance of 7 meters. Calculate the work done. Now, having given a question that a force of 10 Newton is applied to move a bag of cement of 50 kg through a distance of 7 meters. Now, he said we should calculate the work done. Now, what comes to your mind? Let me say this in physics. It's so funny, but then let me say this in physics. This question can even tell you, take G. Take G to be what? 10 meters per second square. But then, I can tell you categorically, for free, that physics is so funny, because there are some parameters that will be given to you that you don't need. Sincerely, one thing first, you need to understand what you want to get. Physics, while solving physics, you have to be purposeful. Are we together? That is, we know that we are taught to calculate what? Work done. Now, we've not moved to work done in force field. We're still going to that, actually. So, now, check out the parameters that you need to solve this question. They will give you parameters, or the questions will provide parameters that you don't need. That's why you need to be definite about what you want to get, actually. So now, I know to get my work done in this point, I'm still working with this formula. W equals what? Force times what? Distance. Are we together? W equals to force times what? Force times distance. Now, if that is the case, then I will say, I don't need this. I don't need the weight of the cement. We don't need it. What we need here is that a force of 10 Newton is applied to what? To move a bag of cement, 50 kilogram rather, through a distance of what? 7 meters. Now, given parameters that we need, so force is what? Is 10 Newton. And what? Distance is what? 7 meters. So then we can what? We can solve what we want. Now, solving this question is very easy. Like, we've actually simplified it further. So what we need to do, let's rub this. So what we need to do here is to say Work done equals to what? Force times distance. Work done equals to solution. Work done equals to force times what? Times distance. Then work done equals to 10 times 7. Work done equals to 70 joule or 70 Newton meter, depending on what the parameters, depending on what the unit is saying inside the what? Inside the question. So now, have we seen it? Have we seen it? This is what the question is saying. But one thing that people keep making the mistake is that we tend to see different parameters, plenty parameters. We want to work with everything, of which physics is not like that. Physics is not like that. So now let's talk about work done at an angle. Work done at an what? At an angle. Okay? Work done at an angle. Okay. Now, what I want to explain here, we have to be very, very careful. We have to be very, very careful. Now, let me do this. So, are we together? Now, in this case now, we want to find this is the force that is dragging this body. This is it. This moving this body from position A to position B. Now, in this case now, there are two things involved. Excuse me. Let's rub this so that we can have a free space to work. Now, we said that in this case, we are going to look at something. This is the force that actually pulling this body from body A to to body B. Let's say a toy car, and you attach a rope to a toy car. Now, you don't go to the level of the car and start dragging it. Now, the rope will be at an angle to that car. Are we together? Or an ice block, a very big one. You attach a rope to it and you are dragging it. Mind you, the whatever object you attach to that rope, either the car or the ice block, will be moving horizontally on the ground, whereas you are pulling it, you will be pulling it at an angle. Are we together? You'll be pulling it at an angle. At that angle, this is the force and this is the angle at which you are pulling it. Mind you, as you are pulling, the object is is moving horizontally. Are we together? The object is moving horizontally. Are we together? So that is the horizontal component of this force. The horizontal component of this force will be what are we going to say is is the horizontal component of this force. Now, what force will lift this object? What force will drag this object towards the horizontal? Now, the horizontal component of this force is just the horizontal component of the force will be will be distance multiplied by by cos theta. Are we together? that will be the horizontal component of the force. Now, in that case, work done here, will be what? F times what? Times horizontal component of the force times horizontal component. Now, finally, work done will be force times S cos theta. So that would be force in what? That would be the work done in what? In a force, in work done at what? At an angle. Are we together? Work done at an angle. Let's take, for example, a man attach, okay, a man drags a toy car with a rope attached to the car, with a rope attached to the car with a force of 100 Newton, and the car makes angle 30 degrees to the ground. Calculate work done by the man. So calculate work done. Now, this is it. It said a man drags a toy car. Just so you know, this is what? The practical example. Are we together? Oh, we missed out something. Now, a man drags out a toy car with a rope attached to the car with a force of what? 100 Newton. And the car makes angle 30 to the ground. So, with distance 5 meters. So, let's just attach it like that. Pardon me. So now, this is the question. This is the force. This is the force. This is the distance. And this is the angle. Are we together? So, and this is the angle. So what we need to do now is just to what? To say solution. That's the given parameters. Force is what? Is 100 Newton. The distance is what? 5 meters. So, and the theta is actually what? 30 degrees. Are we together? So, the theta is what? Is 30 degrees. So, let's rub this. Let's rub this. So, now, we said work done equals to Fs cos theta. Are we together? So, work done equals to, force is what? 100, 5 times what? Cos 30. Now, in special angle, we're still going to talk about this in maths. So, in special angle, cos 30 is what? Root 3 over 2. And how do we get that? Let me just quickly explain that. So, here is 60, here is 60, here also is 60. Equilateral triangle. So, here is 2, here is 2. So, here is also what? 2. If I dissect this, if I bisect it into 2, so here will be what? Here will be 1. Here also will be 1. So if I have a right angle triangle, here, if it cuts this angle into 2, here will be 30, here will be what? 60. So we have what? We have 2 here, we have 1 here. Solving by Pythagoras, that's what? The side facing 90 degree is what? Is the hypotenuse. So here is the opposite to 30, adjacent to 60. So to get this, we can just call it x, and that's what? 2 square, that's the hypotenuse square, equals to adjacent square plus opposite square. So this 4, this 1, this x square. Then we can say it's what? X square equals to 4 minus 1. X square equals to what? 3. So x equals to what? Root 3. So here you have it to be what? To be root 3. So if you want to say cos 30, cos 30 is what? Adjacent over hypotenuse. That's what? Root 3 over 2. In a lay language, root 3 over 2 is same thing as 0.8660. Are we together? So this is just by the way. Actually, I just want to tell you how cos 30 amount to root 3 over 2. So that's just by the way. So now, then we can say W equals to 100 times 5 times root 3 over 2. 100 times 5 times root 3 over 2. So we can say 2 here 1, 2 here 50. So that's work done equals to 250 root 3 joules. So, and you can multiply root 3 is same thing as 1.732. I said root 3 over 2. This cos 30 is same thing as what? 0.860. So, but if we are not using the decimal, we can use the surd form. In maths or in further maths rather, we are still going to do surd. So I will explain every operation about this. Just do well to follow our videos on our YouTube channel, like, subscribe, and share. So let's continue. That's what 250 root 3 joules. Are we together? So this is the work done by the man. Are we together? So that is everything. That's everything we're actually talking about. So now, lastly, on work done, let's talk about work done in a force field. Now, work done in a force field. When we talk about force field are force felt at distance. Now, there are 2 types of force. There are, let's say, contact force and what? And force field. Contact force are all those forces of pull, push. Are we together? Tension force, they are contact force. They are forces that before you can apply to the object, you have to have a contact. And that is why it is called contact force. Now, force field are forces felt at distance. They are forces felt at distance. And the main reason why they are forces felt at distance, we talk about what? The influence of gravity there. That's why they are forces felt at distance. And that's the main reason why if I throw this marker up, it's surely coming down. If I throw it up, it's surely coming down because it attracts a center of what? Of gravity towards what? The earth's surface. Are we together? So now, force felt at distance, the presence of what? Of gravity. And there are 3 types of force field: gravitational field, magnetic field, and the third one is electric field. Now, the presence of gravity in a force field, brings about free fall. Now, when we talk about free fall, we are talking about in a force field, meaning we are talking about lifting of a body. When a body is lifting of a body, so which is upward force. So, and the second one, a falling body. That's this one is what? Against gravity. And this is what? Towards what? Gravity. So that's with the aid of gravity. So are we together? Now, for this now, let's say we're talking about what? A falling body. The body falls from height. So here, normally in work done, we are talking about distance, but in force field now, we're talking about what? Height. Are we together? We're talking about what? Acceleration due to gravity also. Then we are talking about what? The mass of the body. We're talking about the mass of the body. Now, let's take for example, a cement which weighs, so they said a cement which weighs 50 kg is lifted through a height 20 meters above the ground. They said calculate the work done. Take G to be 10 meters per second square. Now, solution. The given parameters are what we write out first. Mass is 50 kg. Now, the height is what? 20 meters. And G, as we all know, is what? What's it called? G, as we know, is the acceleration due to gravity. Now, in this case, then we say, work done itself in a force field is what? M times G times H. That's what? M times G times H. Of which we know that previously we said work done is what? Force times distance. But here now, the force is what? Mass times acceleration due to gravity. And the distance now, we are now talking about distance. We are now talking about what? Height. So this is it. So the unit of work done is still what? Joule or 1 Newton meter. Earlier I said 1 Newton, I put slash here. It's actually an oversight. So it's 1 Newton meter because Newton times meter is same thing as what? Newton meter. So that's the correct thing. Now, we said work done is, okay, so we said work done is what? Mass times G times H. Then work done equals to 50 times 10 times 20. 50 times 10 times 20. We have 0, 0, 0. That's 3 zeros. So 5 times 2, 10. So we have 10,000 joules. Or we call it 10 kilojoules. So now that is solving work done in what? In a force field. That's solving work done in a force field. Then what next? We move to power, and we move to energy. Now, they said energy is the capacity or ability to do work. So we move to energy. Now, we said energy is the ability to do work. Now, what are the forms of energy that we have? We move to energy. We said energy is the ability to do work. Now, we have what? We have forms of energy. We have forms of energy. So we have forms of energy. So which is what? Which is solar energy. We just mentioned example. So energy derived from sun. So chemical energy. Chemical energy. So 3, we have light energy. We have light energy. So 4, we have what? We have mechanical. We have 5, we say electrical energy. So 6, you can say it is what's it called? Thermal energy or heat energy. So thermal energy. So now we can talk about now all these ones, they are part of non-renew and they are part of renewable energy. Like solar now, it's directly gotten from the sun. So a non-renewable energy could be energy that renewable energy are energy that are not used up, like they form a cycle. So but then renewable energy are energy that you retract them, you can't get them back, just like fossil fuel, diesel and all of that. So kinds let's talk about kinds of what? Of energy. Now, one, we talk about what? Potential energy. So there are some kinds of energy, they are part of what? Mechanical energy. So let's say kinds of energy, we talk about what? Potential energy. Now, potential energy are energy possessed possessed by energy possessed by by virtue of its motion. Energy possessed by virtue of its motion. Are we together? Or of its position, rather. Of its position. So they are stored energy, or you say they are what? They are stored energy. Are we together? So potential energy, PE, you said it is what? Mass times gravity times height. So our energy possessed by virtue of its position, or they are what? Stored energy. Now, talking about what? The second kinds of energy, we talk about what? Kinetic energy. We talk about kinetic. Number 2, we talk about kinetic energy. And kinetic energy, we said they are energy possessed by virtue of its motion. So they are moving energy. They are moving energy. So now we can say Ke is what? Half times m, which is the mass, times velocity square. So then we say that where m is what? Is the mass, and v is what? Is the velocity. And v is the velocity. So from there, we can have one or two work example, and we move to law of conservation of what? Of energy. So let's move to laws of conservation of, okay, laws of conservation of energy. So it's at, this is at max height, so this is at ground level. This is at ground level. So at max height, PE, potential energy, is what? Is maximum. So let's say this falling body. Now potential energy is maximum, but kinetic energy at this point, kinetic energy at maximum height is 0. Kinetic energy is 0. Ke is 0. And Pe is what? Is maximum. Are we together? So now this body is falling. Now at this center, Pe plus Ke equals to 0. Now at ground level, Ke is maximum, and Pe is 0. Are we together? Now, law of conservation of energy. Law of conservation of energy states that in an isolated or closed system, the total amount of energy is what? Is constant. So here we can say that Pe plus Ke equals to what? Equals to constant. Are we together? So that is, we can say Pe plus Ke is what? Is constant. Are we together? So now, or we say that law of conservation of energy says that energy can neither be created nor destroyed, but can be changed from one form to another. So now we can say energy at maximum height equals to energy at ground level, which means that Ke is 0 and P is maximum. So Pe plus Ke equals to Pe plus Ke. Now P is maximum, Ke is 0, that's Pe plus kinetic energy 0. At ground level, potential energy also equals to 0. So potential energy equals to 0 and Ke. So now, that is, this is mgh equals to what? Half mv square. So just so we know that the mass is the same thing. Now, gh, that will cancel out. So it will be v square over 2. Then we can what? Cross multiply. Are we together? then we can cross multiply, then we can actually say this square equals to 2gh. Then we can find the square root of both sides. So therefore, velocity is now what? Root 2gh. So that is the velocity of what? Of the energy conserved. So now we can deal with some solved examples. We can deal with some worked examples. Then we move towards power. Then we end it there. So now, example. It said calculate the kinetic energy of a body of mass 10 kilogram moving with a velocity of 5 meters per second. Now, this is straight and direct. That is, it said we should calculate the kinetic energy of a body of mass 10 kilogram moving with what? A velocity of what? Of 5 meters per second. Now, the given parameters, we have mass of the body 10 kilogram. So we have velocity of the body, that's 5 meters per second. Mass is 10 kg. So we can say kinetic energy equals to half mv square. Then we say that's 1/2 times n, that's 10, v square, that's 5 square, that's 25. So 2 here, 1, 2 here, 5 times 5, that's 125 joules. So let's talk about this WAEC example. Example 2. It said a stone of mass 2 kilogram is dropped from a tree. It's dropped from a tree of height. It's dropped from a tree of height 10 meters. So what is its velocity just before hitting the ground? Before hitting the ground. So now, solution. This is typically what? Law of conservation of energy, because we was talking about what? A stone of mass 2 kg. This is at a position. Is dropped from a tree of height 10 meters. So what it is velocity, which means that potential energy would be equals to what? Kinetic energy just before it hits the ground. So that's what? Potential energy PE plus what? KE, we've established that. So that's what? PE equals to what? KE, which mgh equals to half mv squared. We said m cancel, so we are not using what? The mass. So we said v square over 2 equals to what? Gh. Now, what are we told to find? We are told to find the velocity just before it hits the ground. So, well, okay, just before it hits the ground, then so velocity square equals to what? Root 2gh. So velocity equals to 2 times g is what? He said take g to be what? 10 meters per second square. So 10, and the height also is what? The height also is what? Is 10. The height also is 10. So we can now say that, oh, let's rub this. Let's rub this. So we can say, so we can then say that velocity equals to 10 times 10, that's 100. That's what? 200. So velocity equals to what? 14.14 meter per second. 14.14 meter per second, or you say 10 root 2. Are we together? Because square root of 100 is 10. So 10 root 2 meter per second. So are we together? Then from there we can move to what? We can move to power. From there we can move to power. We said power is the time rate of doing work, or some textbook will say it is the rate at which work is done. Some textbook will say it is the rate at which what? Work is done. So power is measured, okay, let's say the unit of power is what? Work done. No, the formula for power is what? Work done over what? Over time. Is work done over time. Then we can units, the units of power is measured in watts. So are we together? So 1 watt, the unit for work done is joule, equals to 1 joule over 1 seconds. The unit of time is seconds. So we can say that 1 watt equals to 1 joule per seconds. Are we together? So 1 joule per seconds. So therefore, other formula for power could be this. Let's say formula for work done is what? Force times distance. Force times distance and what? Over time. Are we together? Now, in a force field, I've explained this earlier, so I won't dwell too much here. In a force field, we said work done in a force field is what? Is M times G times what? Times H. So therefore, power in a force field will be equals to what? mgh over what? Over time, which is what? Work done over time. Are we together? So that's what? In a force field, this is what? This is the power. Are we together? So this is what? This is the power in a force field. So some textbook, some questions will tell you, find the engine speed. So that is what? So that is, what's it called? Force times distance. So mg, that's what? That's this force times height over time, like that. When we get to solve questions like that, we'll talk about it. So let's solve worked examples. Let's solve worked examples. So example 1. Example 1 said a boy runs up a boy of mass 5 kilogram runs up a set runs up 10 sets of steps Are we together? Runs up 10 sets of steps of each height 0.2 meters. Of each height 0.2 meters in 5 seconds. In 5 seconds. He said calculate the power exerted by the boy. Calculate the power exerted by the boy. So solution. So that is what the power equals to what? Okay, let's get out the parameters. M, which is the mass, is 5 kg. Now, we are given G to be 10 meter per second square. Now, the height now, he said runs up what? 10 sets of steps. That is, it will be like this. It will be like this in this form. So each height will be 0.2 meter each. So they now said 10 of it, which means the total height will be what? 0.2 times what? Times 10, which is what? 2 meter. Are we together? That's not the final answer. Then we will now what? Calculate the work done. We'll calculate the power. We don't need to calculate them differently. We'll calculate the power. So that will be what? mgh over what? Over time. mgh over time. Are we together? So that's power equals to mass times gravity times height over time. So then we can say power equals to 5 times 10 times 2 over what? Over 5. Because it said in 5 seconds. So 5 cancel 5. The power is equals to what? 20 watts. Are we together? So the power equals to 20 watts. Now, they can also give you power in form of what? Engine speed. That is work done. Work done is what? Force times distance over time. So we know distance over time is what? Is speed, which is the velocity. So power equals what? Force times what? Velocity. So formula for power can actually what? Come in this form also. Now, and 1 horsepower equals to 746 watts. Are we together? So equals to 746 watts. So of which will be what? 0.75. We can say 0.75 or 0.746 kilowatts. For 1 horsepower equals to 746 watts. In case question give us the thing to calculate in watts, in horsepower, calculate in horsepower. So that's what we just do. We just convert like that, and that brings us to the end of work, energy, and power. Subsequently, we'll be solving WAEC-based questions on work, energy, and power. You can do well to like our page, subscribe, and put down a comment, at least to help us in our subsequent classes that will still be dropping. Thank you so much.